In March 1972, the Club of Rome published the findings from their project on the predicament of mankind. It was based on the work of Professor J. Forrester. This warehouse building at the Massachusetts Institute of Technology is Forrester's laboratory. Here, he pioneered techniques for modeling the dynamics of complex systems. He has tackled problems ranging from drug addiction in towns to the running of an industry. During the 60s, he built up a team of engineers and social scientists to develop these techniques. In 1970, he embarked on the first computer model of the world.
Many of the most powerful traditions and goals in the world today revolve around the processes of growth. Growth in standard of living, economic growth, growth of populations, until very recent times, the expansion of geographical frontiers. Growth, in some sense, has dominated perhaps the last 1,000 years of history. Now, this growth is going to stop. It must stop, and it will stop. The only important question is by what process? What process will stop it? Will it be a natural process? Will it be brought to an end by pollution, by running out of food, by sheer crowding and the kinds of conflict and epidemics that may come from this? Or will this growth be brought into equilibrium by some more rational process that is less traumatic, less difficult than the great pressures that will arise if we depend only on the natural and social processes that now seem to be at work. We're working here on the dynamics of social systems, coming to a better understanding of the way in which our social systems behave. And what we seem to be discovering is the deficiency of the human mind in dealing with the dynamic, the time-varying behavior of a system as complicated as any of our social systems. These are far more complex systems than any of our engineering systems. And yet, if we try to understand an engineering system, we always build a model, we build a prototype, we do experiments in order to design it better. And our social systems are a great deal more complex.
J. Forrester has made an important step forward. He has proposed and offered and tried a methodology to reduce the complexities of the world in something simple and understandable. It is not the ultimate methodology. It has been very heavily criticized, but nobody else has ever tried to do the same. So hats down to J. Forrester. This is one level. The methodology.
This is a conference organized by the Club of Rome. Its purpose is to inform and involve key industrialists in the environmental problems of the world. Dr. Aurelio Pace, its chairman, created the Club of Rome in 1968 in order to focus attention on these problems. The club's members are an invited group of about 70 eminent men. Their aim is to draw attention to the complex of problems facing the world today by individual contact with industrialists and key people in government throughout the world on both sides of the Iron Curtain. The club also promotes research into these urgent problems which the politicians have so far left untouched.
What we succeeded in doing so far was to convince many people around the world, people in science, philosophers, in people teaching in university, in other schools, the political class here and there, members of the business communities, that the time has come to a real fundamental reassessment of our condition, and probably a great change of course.
Dr. Alexander King is Director General of Scientific Affairs at the Organization for Economic Cooperation and Development in Paris. OECD is an international organization set up in 1960 to coordinate the economic policies of governments in Europe, Asia and the United States. During the war, Dr. King was scientific advisor to the British government. He was the man who decided that we should manufacture and use DDT to protect the forces in Burma against malaria. The Club of Rome was conceived by these two men.
The technological consequences are not just in pollution. The whole question of the lack of satisfaction in work, for example, is part of the same problem. The problems of the cluttering up of the cities, of drug taking and delinquency and increasing the crime rate. All these things are connected as part of one of the, as parts of one very big problem.
Let's take population. The simplest way to consider population is that if population grows, we will try to find food for that population. But to have that food prepared, we need more industry. Industry will require materials, new land. That new land will itself require some kind of reclamation or destruction of vegetable green plants and then transport across the seas and so on. So we see that one simple phenomenon, that the birth of a new child in the United States or in India entails an enormous quantity of modifications to the present situation. It is said that it should be much more important to limit the growth of population in the United States than not say in India, contrary to the normal popular wisdom, because a new child in the United States requires 75 more new things than an Indian child.
To my mind, the first thing to do is to learn what the problem really is and what the connections are. Some people say that this complex, this cluster of problems, has become so complicated and interacting that we're passing the time when there can be simple problems and simple solutions. Because in attempting to solve one bit of the problem, say a particular pollution problem, one is really looking at a symptom without having diagnosed the nature of the disease. And curing a symptom may lead to other symptoms appearing in other parts of the system caused by this change, and we hardly recognize that that has happened. So to my mind, one of the important things for science and technology, indeed for man, is to try and find out what really is happening, how the system works, so that we try to learn how to manage it.
In July 1970, they launched their first project, an attempt to make a theoretical model of the world as a system. It was sponsored by the Volkswagen Foundation and based on the work of Professor Forrester.
The problem here is that these systems are what we have come to call counterintuitive. They do not behave the way we think they do. We expect, for example, that cause and effect will be closely related in time and in space. If one trips over the threshold and falls down, happens now, the reason is clear. It's because he stubbed his toe, and we expect this close coupling between cause and effect, and the close coupling in time between when the cause occurs and when the effect occurs. But as one goes into the more complicated systems, one finds that there are no cause and effect simple relationships, that it's the structure of the entire system that gives it the behavior. No one thing causes something else, but the entire set of interactions produce the total behavior.
This is the flow diagram of the first prototype model. It looked at the complex network of interactions between 5 critical indicators of the world system: the level of population, the level of pollution, the natural resources that are as yet unused, the amount of capital investment, a measure of things like factories, machines, power stations, roads, schools and hospitals. and lastly, our capacity to produce food. The values of these 5 indicators give you a rough description of the world at any moment. The next step was to find the ways they changed, the rates of flow in the system. Take population level. It depends on birth rate and death rate. Birth rate here means the annual number of births. It increases the population level. Death rate decreases it. But the levels themselves influence the rates. In a larger population, there are more people to breed and more to die. The model is a vast system of feedback loops like these two. The critical problem for Forrester was to identify just what factors influence each rate and how. Take the death rate. The amount of pollution in the world environment obviously affects the death rate. So do many other factors, for example these. Forrester and his team held hundreds of meetings with experts in a wide variety of fields, doctors, psychologists, economists, experts from all branches of the social sciences, in order to estimate how the various factors might influence the death rate. Take the multiplier relating death rate to pollution. Death from pollution is a relatively new phenomenon of the 20th century, and there's very little precise information about it. We do know that sudden sharp increases in pollution cause sharp increases in death rate. The 1952 smog in London caused the deaths of 4,000 people in a month. While today, in Japan, hundreds of people are crippled and dying as a result of metal poisoning from chemical wastes discharged into the sea and into the irrigation systems of the rice fields. Less dramatic, but more insidious and widespread effects than these provided the information for the model which allowed Forrester to begin to quantify the effect of pollution on the death rate. DRPM is the coding for the effect of pollution on death rate. Pollution is measured as the ratio to the world level in 1970. If the pollution level rises by a factor of 20, the death rate doubles. 60 times as much pollution and the death rate goes up by a factor of nearly 10. All the other levels and rates had to be analyzed in this way. Pollution level is reduced by natural cycles in the environment and increased by the generation of waste. Pollution generation is influenced by capital investment. More industrialization produces more pollution. Natural resources are depleted according to our material standard of living. Birth rate is affected by food production, by crowding, by pollution, by material standard of living. Once Forrester had identified all these interactions and quantified them, he used a computer to find their combined effects.
We are combining the great ability of the human mind to perceive the individual motivations, the individual actions within the system, and then we combine the policies, we combine the criteria or the rationale under which the various parts are working. We combine those into a system model which allows us to tell what happens when all of the separate pieces interact with each other. Now, that the computer does very well. The computer does not provide the original input information. It does not provide the perceptions on which a model is based, but it can trace through all of the interactions once we have given it the rules under which the various parts of the system seem to be acting. A lot of people believe this is impossible because they feel that one cannot make a model of anything as complicated as a social system. And of course they are partially correct. A model is a great simplification. But we have no choice about the use of models. The mental image that we use for passing laws, for running cities, for operating a government, these mental images are models, because one does not have a city or a country or a world in his head. He only has certain images which are models. And so the question now is that model adequate is it the best model which we can make? And the answer is no. It is not the best model which we can make.
However, the model did show a remarkably accurate response when started from known data for the year 1900. If one now lets the model run on, it shows these consequences. As population and capital investment increased during the first 120 years, natural resources declined steadily. By 2020, they've declined so far that the world cannot continue to support the expanded population. Population and capital investment begin to diminish. The computer also plots out a measure called the quality of life, which is a kind of index based on food supply, crowding, and pollution. Quality of life falls off because of the pressures created by the shortage of natural resources. The most striking implication for the quality of life in this particular run lies in the fact that it reached its peak in about 1960. By 1970, it's already fallen off slightly, and after that the fall-off is sharper, implying that the 60s were a golden age. Forrester speculates that it may not be a coincidence that the late 60s and early 70s have been accompanied by rising social unrest. The value of the model is that you can vary all the rates, try different relationships and multiplier values to see how it affects the predictions, to see which are the sensitive relationships that need accuracy and which can be left rough. Forrester used the model to test out the effect on the whole system of a variety of strategies that might be tried to avert a crisis. Suppose, for example, that we managed almost instantaneously to cut down on natural resource usage by 75%. Keeping all other levels at their 1970 value, the model shows this. A crisis in 2040, with a sudden violent growth of pollution and a traumatic fall in population.
We are talking here about a new profession, the profession of the dynamics of social systems. It is just as difficult to learn as law or engineering or medicine. There are no schools that are fully developed yet. It's just the beginning of a whole new frontier. I myself believe that it is a frontier as big and as important as the frontier of science and technology which we have been through over the last 40 or 50 years. These frontiers come, they are pioneered, and they recede into the fabric, the everyday behavior, everyday work of our society. And the question is, what frontier is next? What comes after the frontier of science and technology? Because science and technology is no longer a frontier. It has been pioneered. It is a part of everyday living. And what is the next frontier? I believe it will be this understanding of the nature of our social systems all the way from the family to international power politics.
In 1970, under the leadership of Professor Dennis Meadows, an international group of researchers joined together at MIT to develop a more refined version of Forrester's model. They kept to the same 5 levels, but incorporated hundreds more factors. They used it to test out the long-term effect of various policies which might improve the world situation. If you stabilize population by improved birth control methods so that birth rate equals death rate, this is what happens. The fast initial growth of industrial and agricultural output collapses with the decline of natural resources. The effect of another policy, stabilized population and capital, was this. Food and industrial output stabilize at a high level for some time. Then, towards the end of the next century, natural resource depletion produces fall-off again. One run produced this. A stable picture. Against a background of falling resources, it maintained our current level of food and industrial production. It did it by a subtle combination of carefully timed policies. Among other things, transferring capital investment to agriculture, education and health services, and away from factory-made goods.
That project, the initial project to better understand the new situation of man on his planet, was not made to find answers. We may say that it was made in order to put the right questions, to let people think through what is, we call, the predicament of mankind.
Governments in democratic societies are organized in parliamentary terms of 4 to 5 years. And this, in order to get popularity, to win votes at the next election, makes any government look at the long-term immediate issues which will affect the people and affect their voting. And therefore, longer-term problems tend to be put off. Until fairly recently, this didn't matter very much because the long-term things came home to roost in about 20 years' time, and one could make up towards it gradually. But now, with the rapid rate of change of science and technology, but also of social affairs, political affairs, population, everything, what were formerly long-term type of problems tend to become aggravated in 5 to 7 years, i.e. in the next political term. And this is an inherent difficulty, I think, with our democratic system, which we may have to look into.
We have to face this mass of problems with a new mentality, new approach, that we have to change some of our ingrained habits, some of our petty ideas, the ways of life that we had so far, because now we are probably against a wall, the boundaries of the system. That is the first, the immediate need, I think. The concept of the spaceship Earth, which I think was first brought out by Barbara Ward, that is that we are in a kind of ship going through the skies, is very important in this sense, because it must give us a new sense of solidarity with all the people who happen to be in that ship. But there is perhaps something a little more profound than that. We should not consider that ship like a luxury liner, an ocean-going big ship in which there are passengers of first, second and third class. We must consider that probably at a certain moment when the limits of our environment, of our world, and some ecological imperatives that we have to respect, the mentality of the people will not be thus that of the passengers of a liner, but probably that of the people on a lifeboat, where we have to survive